Hello, this is the second video for chapter Work, Energy and Power. In the first video we learned definition of work, its SI and the CJS unit and the relation between them, also the relation between the joule and the erg. Also we learned how to define 1 erg of work, 1 joule of work. Okay, and we learned finding the component of displacement along force and finding the component of force along displacement. Okay, and we learned formula work is equals to force into displacement into cos theta, where theta is the angle between the force and the displacement. Okay, let's take one simple example. So every day we go to school, we do a lot of classes, we play with our friends, and we have to walk all the way from home to school and from school to home, and we felt like we did lot of work because we got so much tired, but from physics point of view our work done is zero. Why? Because our initial and the final position is same. Okay, when the initial and the final position is same, our displacement will be zero. When the displacement is zero, then the work done will be zero. Okay, and in today's class we learn more about the work, when the work done is positive, when it is negative, and when it is zero. Case 1. If the displacement is in the direction of force, that is when theta is equals to 0 degree here, because work done is your force into displacement into cos theta. Okay, so first I'll write for cos theta. Okay, when theta is here 0 degree, this is 1. Okay, the value of cos theta is 1. When the cos theta is here 90 degree, this will be 0, and the cos theta is 180 degree, this will be minus 1. Okay, these values you have to know, okay, to understand the three cases of work done. Okay, so the case 1 is here, if the displacement is in the direction of the force, or when the theta is 0 degree. Let's take one example. If we have a body, okay, and we apply a force on the body, and the body is moving in the direction of the force. Okay, that means displacement is towards the direction of the force. At that time, angle between the force and the displacement, that means theta will become 0 degree. In that place, we know that cos 0 degree is equals to 1. Therefore, work done is equals to force into displacement cos theta. That means force into displacement cos theta is here cos 0 degree, and cos 0 degree is equals to 1, that is force into displacement. Okay, so that means at that time your work done is positive. Okay, so that means when the force and the displacement is along the same direction, then your work done is said to be positive. Let's take one example. If you have a ball and which is falling freely downwards, so here the displacement is towards the downward direction, and the force applied here is also the downward, because here the gravity is pulling the ball in the downward direction. Displacement is downward direction, and even the force is falling down, that means it is also in the downward direction. At that time, that means we can see here force and the displacement is along the same direction. Okay, so when it is along the same direction, angle between the force and the displacement will be 0, then your work done will be positive. Let's take another example. If we have a load here, okay, and we are trying to lift the load by height h here, the load you lift here. So that means here when you lifting the load, so displacement will be towards the upward direction, and the force we are applying in order to lift the load, here is the force which is also in the upward direction. So that means here the direction of the displacement and the force is same. So that means here angle between the force and the displacement is 0. When the angle between the force and the displacement is 0, that means cos theta is equals to cos 0 degree. When the and the value of cos 0 degree is here 1. At that time the work done is here positive. These are the cases when the work done is positive. When the work done is positive, when the force and the displacement is along the same direction. Case 2, if the displacement is normal to the direction of force, that is when theta is equals to 90 degree. Let's see what will be the work done. Work done at that time will be force into displacement into cos theta, and force into displacement. Theta is a 90 degree, cos 90 degree, and force into displacement, cos 90 degree is how much? 0. So 0 into any number is a 0. So that means here work done is 0. So in the second case we got when the displacement is normal to the direction of the force, then your work done will be 0. So let's take example when a body is moving in a circular path. Okay, when the body is moving in a circular path, at each instances the body is pulled towards the center of the earth due to the force of gravity, or we can say that due to the centripetal force. Okay, so if this is the center of the gravity, at each instances body is being pulled towards the center of the gravity. This is the force. Force is towards the center of the gravity, and the direction at each point when the body is moving, it will be tangential. Okay, so it will be in this direction. Displacement will be in this direction. At that time angle between the force and the displacement is here 90 degree. Okay, so when the angle between the force and the displacement is 90 degree, so that means your cos theta will be cos 90 degree, and cos 90 degree is 0, then your work done will be 0. So that means every point from here also, if you see that this is the displacement, okay, and the force is applying this direction. This is your force. The force is always directed towards the center of the circle when the body is moving in a circular path. Okay, let's take another example. The earth is going around the sun. Okay, the sun is here. When the earth is going around the sun, the earth is always pulled towards the sun due to the force of gravity. Okay, and the direction of the earth will be in this direction. This will be the displacement. Displacement is forming a tangent. Okay, so here we can say that at every point the force is directing towards the center, that is towards the sun, and the displacement will be towards this direction. Okay, so that means every point the work done will be 0, but only when the body is moving in a circular path. When the displacement is normal to the direction of force, the work done, that means at that time the angle between the force and the displacement will be 90 degree here, 90 degree here. At that time the work done is 0. And the case 3, if the displacement is opposite in the direction of force, displacement is opposite in the direction of force, that is when theta is equal to 180 degree. Let's see, work is equals to force into displacement into cos theta. Here force into displacement, cos theta is how much? Cos 180 degree, and cos 180 degree is here minus 1 is equals to force into displacement into minus 1 minus force into displacement, regardless of any values of force and the displacement. Here work done is negative. Whenever the angle between the force and the displacement is 180 degree, then the work done is negative. So when we'll get the 180 degree? Straight line. So straight angle is a 180 degree. Let's take one example. If the ball is thrown vertically upward. When the ball is thrown vertically upward, displacement will be in the upward direction. It is going in the upward direction. Ball is going in the upward direction, but the force of the gravity is pulling the ball in the downward direction. Here the force is applying here in the downward direction. Here the force and the displacement is in the two opposite direction. When the force and the displacement are in the opposite direction, the angle formed between them, theta here will be 180 degree. Here theta will be 180 degree. So from the definition of the work, we can say that work is equals to force into displacement into cos theta. So that means when theta is 180 degree, it is the value of cos 180 degree is -1. So it will be minus force into displacement. So at that time your work done will be negative. So these are the three cases. When the force and the displacement is towards the same direction, angle formed between them is 0 degree. That is when theta is 0 degree, when theta is 0 degree, your work done will be positive. Okay, case 1. Okay, and when the displacement is normal to the direction of the force, theta will be 90 degree. When the theta is 90 degree, your work done will be 0. And the third case, when the displacement is opposite in the direction of the force, when the displacement is opposite in the direction of the force, or when theta is 180 degree, work done will be negative. These are the three cases. When theta is 0 degree, work done is positive. When theta is 90 degree, work done is 0. And when theta is 180 degree, work done will be negative. You have to know that when the work done is positive, when the work done is 0, and when the work done is negative, because in the Icse often these questions will come. So now by knowing that when the theta is 90 degree, work done is 0. Now we have the three cases when the work done is 0. The case 1, when the force is 0, the work done is 0. 2, when the displacement is 0, work done is 0. And the third case, when the angle between the force and the displacement is 0, work done is 0. These are the three cases when the work done is 0. Also, we have to know when the work done is maximum. When the work done is maximum, angle between the force and the displacement is 0 degree, then we can say that the work done is maximum. Okay, that means when the force and the displacement is along the same direction, at that time the work done will be maximum. So far we have learned that when the work done is positive, when the work done is negative, and when the work done is 0. Quickly we will see the examples of all three cases. First case is here, one is here, when theta is 0 degree, so work done will be positive here. So say if you have a ball and it is falling freely downwards, here the displacement will be towards the downward direction. Okay, and the ball is falling downwards due to the force of the gravity. That means the force of the gravity is pulling the ball downwards. Okay, so that means here the force will also be in the downward direction. So here force and the displacement is towards the same direction. So the angle formed between them is 0 degree. So the work done is positive. If you have a load here and we try to lift this load to a height 5 meter, here we apply a force towards upward direction, and the displacement here we can see is also in the upward direction. Here also the angle between the force and the displacement is 0 degree. So here the work done is again positive. Okay, these are the examples of the work done positive. Okay, and second case is here when theta is equals to 90 degree, work done will be 0. Okay, so say about when a body is moving in a circular path, okay, the force on the body is always directed towards its center. So that means here the force is directed towards the center, and the displacement of the body will be in this direction. So it will be tangential. Okay, so if we make a tangent from that point, then we'll get the displacement here. So here the angle between the force and the displacement is 90 degree. Okay, so when the angle between the force and the displacement is 90 degree, cos theta will be 0. So your work done will be 0. Every point in a circular path, okay, displacement will be the tangent we will draw on that point. This will be the direction of the displacement, and the force is always acted towards its center. The force will be towards its center. So the angle between them is 90 degree. When the angle between the force and the displacement is 90 degree, the work done will be 0. If a coolie is carrying a load on his head, okay, and moving in a horizontal path, so at that time the displacement of the body will be in this direction. So the body will be displaced in this direction, but on that load head, the load is there, the force will be directed towards the downward direction due to the force of the gravity. Here also force and the displacement, that means angle between the force and the displacement is 90 degree. When a coolie is carrying a load on his head and walking in a horizontal path, at that time the force will be directed downwards direction and the displacement will be straight. So at that time the angle formed between the displacement and the force will be 90 degree. So cos 90 degree is equals to 0. Work done is equals to force into displacement into cos theta. Here cos theta is equals to 0. The work done will be 0. Often in the exams, this example of the coolie carrying a load on his head will come. Okay, and the third one is here. So what we have learned, third one is here, when theta is at 180 degree. So the work done will be negative. So simple example, so that means when the work is done against the force of the gravity, then your work done will be 0. So something like that, if the ball is thrown vertically upwards, when the ball is thrown vertically upwards, the ball will move upward direction. It will reaches here, but here direction, that means displacement will be towards this direction. Okay, but whenever ball is going upwards, the constantly ball is being pulled down by the force of gravity. That means force is here towards the downward direction. The force is here towards the downward direction. At that time force and the displacement are to opposite direction. Okay, in that case the angle between the force and displacement will be 180 degree. So when theta is 180 degree, cos theta will be -1. The work done will be negative at that time. Or else, if you have a load here, if we are applying 5 Newton force and here we are applying 10 Newton force. This is your A and this is your B. 10 Newton force is applying this side, okay, and the body will shift this side. So from A point of view, the work done will be positive here. From B point of view, B is trying to pull the body this side and applying a force towards this direction. Okay, but here A is applying more force, then the body will move towards this direction S. Displacement will be towards this direction. At that time, angle between the force and the displacement will be 180 degree. So here the work done by B will be negative, whereas here the force and the displacement is in the same direction. For A, the work done will be positive. Lastly, we have to know that what is a scalar quantity. Often this question comes in our mind, why work is a scalar quantity though force and the displacement is a vector quantity? Because when we do some work, when the force is applied on a body, the body will move. When the body will move means there is some energy. Okay, and energy is a scalar quantity due to which the work is a scalar quantity. Our next topic is power. So first we'll take example. If we have a load 100 kg and load say 80 kg. Okay, here is A and B. We have two persons A and B. A lifts the load of 100 kg to the height of 2 meter, and B also lifts a load of 80 kg to a height of 2 meter. Now let's find the work done by A and B. We know work done is equals to force into displacement. Okay, so here for work done by A, we need to know the force here. We know the that means displacement is 2 meter. Okay, but we don't know the force. We know force is equals to mass into acceleration. Acceleration is what? Here is acceleration we get is acceleration due to gravity, which is 10 meter per second square. Okay, so here this will be mass will be a 100 kilogram into acceleration is a 10 meter per second square. This will get 1000 kg meter per second square, which is equals to 1000 Newton here. Therefore, work done by A is equals to force into displacement. Force is here 1000 Newton. Displacement is here 2 meter. Here work done by A is how much? 2000 Newton meter, which is a joule. And for B, force is equals to mass into acceleration. Mass is here 80 kg. Acceleration is here 10 meter per second square is equals to 800 kg meter per second square, which is equals to 800 Newton here. Therefore, its work done is equals to force 800 Newton into 2 meter. Displacement is equals to 1600 Newton meter, which is equals to 1600 joules. Here we see that the work done by A is 2000 joules and the work done by E is 1600 joules. So the work done by A is greater than work done by B. But here we try to understand the power, how the power is related with the work. Okay, we know that power is the rate of doing work. So mathematically we can write power is equals to work done by time taken. Okay, now if you are to calculate the power of the A and the power of the B, suppose A is taking 40 seconds to lift and B is taking, let's take 20 seconds to lift the load to 2 meter height. Power of A is equals to work done. Work done is here 2000 joules upon time taken is here 40 seconds. So 0, 0 cancel, 4 1 are 4, 4 5 are 20, 0 is equals to 50 joules per second is the power of A, and power of B is equals to work done 1600 joules upon 20 seconds. So 0, 0 cancel, 2 1 are 2, okay. This will be a 2 8 are 16, 0 is equals to 80 joules per second. Power of A here is 50 joules per second and the power of B is here 80 joules per second. Therefore, power of A is less than power of B, because B is doing the same work in lesser time. So, power is the rate of doing work, how fast the work is being done. What is the unit of power? We know that unit of work is your joule, SI unit of work is your joule, and the SI unit of time is your second, is equals to joules by second. That means joules per second is equals to watt. Therefore, watt is the unit of power. This is the SI unit. SI unit of power is a watt and its bigger units are kilowatt, megawatt and the gigawatt, and the smaller units are milliwatt and the microwatt. So the relation with watt is here, 1 kilowatt is equals to 1 to 10 to the power 3 watts. 1 megawatt is equals to 10 to the power 6 watts, and 1 gigawatts is equals to 10 to the power 9 watts. Similarly, smaller units, 1 milliwatt is equals to 10 to the power minus 3 watts, and 1 micro, we write mu w microwatts is equals to 10 to the power minus 6 watts. These are the relation. These are the smaller units and these are the bigger units of power. We have the other unit for the power is the hertz unit, which people used to use in the early ages. 1 hertz power is equals to 746 watt. The power of 1 hertz is 746 watt. Okay, we will do one more example of power. If we say that the power of an electric bulb is 100 watt, power of an electric bulb. If the power of an electric bulb is 100 watt, what do you understand by this? So from this we understand the bulb does 100 joules of work in 1 second, because 100 joules, watt is your joules per second. This bulb does 100 joules of work in 1 second. Similarly, if we say that heater or the power of heater is 1000 watt, this means that the heater does 1000 joules of work in 1 second. Okay, now we have completed work and the power. Let's see difference between them. So first one is the definitions. Work is said to be done when the force is applied on a body, the body displaces towards the direction of the force, and for the power, power is the rate of doing work. And the second one, we can say that work does not depend upon time, and whereas the power depends upon time. And the third one, simply we'll write its units. Okay, SI unit of work is joules, whereas the SI unit of power is watt. And the last topic is our energy. So what is energy? So energy is the ability to do work, or it is a capacity to do work. Units of energy is same as the units of work. So SI unit of energy is a joule. Okay, and similarly CGS unit of energy is a erg. And we have already done, that means relation between joule and the erg, 1 joule is equals to 10 to the power 7 erg. Okay, and the bigger units of energy are watt hour and the kilowatt hour. Bigger units are watt hour and kilowatt hour. All the things like heat energy is measured in calories, and energy of the small particles like atomic particles is measured in electron volt. Okay, this is important in chemistry also. So 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. Okay, which is very small energy. Now let's find the difference between energy and power. Energy and power. First difference, we can write their definitions. Power is the rate of doing work. Okay, and energy is the capacity to do work. Okay, second, same. Power depends upon the time, whereas energy does not depend upon time. Okay, and third unit, SI unit of power is your watt, and the SI unit of energy is your joule. And energy is also a scalar quantity. It is also a scalar quantity. So watt, power and energy, all these three terms are scalar quantities. Now we have completed definitions, units, relations, examples, differences of work, energy and the power. In the next video, we will do different forms of energy.